Hello again. This is the last session for this morning. Please welcome Gisela, who is going to talk about dictionaries behind the scenes.
Hi everyone, thank you so much for being here. My name is Gisela, and today we are going to be talking about Python dictionaries and what's so beautiful about them. Recently, I was reading a book called Fluent Python, very interesting. And within this book, there was a quote. Any running Python program has many dictionaries active at the same time, even if the user's program code doesn't explicitly use a dictionary. And here is in a nutshell why Python dictionaries are so important. Python dictionaries are everywhere, and that is why they are constantly changing, constantly evolving, constantly being optimized with a level of craftsmanship that hopefully this talk will give you a sense of. Let me give you a couple of examples of Python dictionaries being everywhere. When you define a model, imagine your model has a function A and a class B. Well, this behind the scenes creates a dictionary with keys A and B, and the values being the actual objects of the function and the class. So this talk will have three parts. On the first part, we'll talk about hashing and dictionaries and what you can tweak and personalize about this. On the second part, we'll talk about security. Are Python dictionaries secure? And what has been the evolution up to date? And the third part, we'll talk about performance optimizations. Because Python dictionaries are everywhere, it's really important that they are optimized. And in the detail, the attention to details of Python, here we'll see a couple of examples of how that works. So, what is hashing? Hashing, we use it to map arbitrary size data into an integer. And we will demand from a hash function that if two objects are equal, their hashes should be. But now, is any hash function useful or good? Well, no really. If we take the constant function, return 1, this trivially satisfies this, but it wouldn't make use for us. So what do we do with hash functions? We create one of the most beloved data structures for computer science, hash tables. You've probably come across them before, and here they are again. Hash tables are very efficient. Most of the things you want to do with them, you can do them in constant time. And this is roughly how they look. You have your keys, you have your hash function with maps to buckets. Now we were talking about a bad hash function, but then what is a good hash function? What is good hashing? So we will ask for two more things. We will ask that our hash function is cheap to compute. We want to use it often. And we will also ask that it minimizes collisions. What is a collision? Is when two of my keys go to the same bucket. Each time this happens, this degrades the performance of my hash table. And this is a problem that I will have to solve one way or another if I'm talking about hash tables. So in Python, hash tables are used to implement both dictionaries and sets. And this is why maybe when you were starting to code in Python, you came across this type of error. You created, for example, a list, and then you created a dictionary, and you try to use your list as a key for your dictionary. And you get type error, unhashable type list. So what is unhashable? And what is hashable for that matter? So this is the official definition of hashable. An object is hashable if it has a hash value which never changes during its lifetime and can be compared to other objects. Hashable objects which compare equal, must have the same hash value. Hashability makes an object usable as a dictionary key or a set member. So this is the definition, we have read it. Let's digest it a bit more. It has a hash value. This under the scenes means that it needs a dunder hash method, which never changes during this lifetime. This means that it will not be able to depend, it cannot depend on mutable attributes. And it can be compared to other objects. This means under the scenes that it needs a dunder egg method. So, are user-defined objects hashable? Do they have this dunder egg, this dunder hash? By default, yes. And the dunder egg is the identity. So two objects are equal if and only if they are the same object. If this doesn't quite work for you, you can override both of these things. You can override dunder egg and you can override dunder hash. But you must proceed with caution because there can be side effects if you do it wrong. So let me give you what it says here. If you override dunder egg because you say, this equality concept doesn't work for me, but you forget to override dunder hash, Python takes away from you the hashability of your objects. If you, for some reason, don't want your objects to be hashable, the best thing to do is explicitly set dunder hash to none. And then you can go ahead and do that. But if you do want a hashability and you do want to override this, then there are a couple of things to consider. First, remember that the attributes you use cannot change during their lifetime. But also, Python doesn't leave you alone, and it doesn't mean you need to become a cryptographer to override this dunder hash method. You can use the built-in function hash and pass whatever attributes your class has. Let me give you an example. I don't know if you can see, maybe it's a little small, but I will read every. So we are defining a class person, and we define an init which takes just one argument, and it defines self.name to that. So this person has a name. And then we override dunder hash by calling the built-in hash function with self.name. And this is something very standard. We usually override dunder hash by calling the hash method with a tuple of unmutable attributes. And then we override dunder egg. In this case, in a very simplified model, we take two persons to be the same if they have the same name. So to wrap it up, Python hashing is personalized, and you can tweak this to your convenience if the standard way doesn't work for you, but you have to remember to do both and to proceed with some caution. So let's move to security. Are Python dictionaries vulnerable to bad actors taking advantage of them? Let's talk about, for example, an HTTP server with a get query string. This is usually parsed into a dictionary. So again, I'm not sure if you can see the URL, but I have highlighted in bold what would be mapped to the keys of this dictionary. You can see straight away that you don't have control of how many keys you will have or what the keys will be. So when you're in this situation, if the attacker knows your hash function, that means they can give you keys designed to collide, and as many as they want. So this puts you in a position where you are prone to a denial of service vulnerability. There are more examples of this kind of situation. When you parse a JSON, this also produces a dict. When you're uploading a CSV file, this also goes to a dict. And in general, in any scenario where you don't control the keys and you don't control how many they are, you are kind of exposed. So what has happened? What has been the evolution going in dictionary security. Our first version was vulnerable to this. It was a non-cryptographic hash algorithm similar to FMB. It was very efficient, but it leaves you prone to this denial of service type of attack. This was something the community was aware for a while, but it wasn't a high priority. And then it got prioritized, and we moved to the second version on this evolution. It was still FMB, but we added some random prefix and some random suffixes to it in an attempt to make it harder for attackers. There was never an attack with this, but theoretically the vulnerability was still there. And also, there was really a penalty in performance to be paid for these randomizations to be added. So all in all, we came to the last version, which is what we enjoy today, SIP hash. SIP hash is a family of pseudo-random functions which are as efficient, almost, as what we have in the naive first prone-to-attack versions. So where do your applications stand? If you have your code, what are you really using? This is the snapshot of all supported Python versions today. If you are up to date and you have migrated your code to Python 3, then congratulations, you're on the most secure version of Python dictionaries we have known. And now we come back to what I said at the beginning. Python dictionaries are everywhere. And because they are everywhere, there is a level of optimization that it really escapes sometimes your imagination, the level of detailing. And these are just 3 examples that I chose because I find them interesting and hopefully they give an idea. The first one is space optimization. This was proposed by Hettinger. What you see here is a dictionary. And what you see here is also a dictionary. This is on the left, we have the old version. It was each row is an entry to my dictionary, and this was kept as a sparse table. The invariant was that certain percentage of the table had to be empty at all times. So if you keep adding things, this will keep resizing, and there will always be that wasted space. So then, this was proposed. And this keeps a dense table. Here, in case you don't see it in the back, this is just the hash of the keys, and the values of the dictionary. In the new version, we have a compact table and a sparse array. And this saves a lot of space for us. When this optimization came, it didn't change any of the functionality, any of the hashing algorithm. It only reduced the space that we needed to storage. But it also made iteration faster, resizing faster, and as a side effect, and a quite nice one maybe, now the dictionaries remember the order of the items inserted. This is a nice one, key sharing. So here we are talking of another example of Python dictionaries being everywhere. So let's take the instances of your class, the attribute dictionaries that live behind that. And this is an optimization for that. So those dictionaries will share the keys, and it will save up to 20% of memory. And here, let me give you an example that will maybe help visualize this. If I have, this is the same dictionary of the previous slides of the other optimization, right? So I have my class, and I have one instance, P1. And actually, P1 will look like this. So actually, this compact table that I was talking about is split in two. And I keep the values next to my sparse index, but I keep the keys and the hashes of the keys just with a pointer. And why? What happens if I create another instance? If I create another instance, then I also just give them a pointer to the same one. And if I create thousands of millions of instances of my class, this will be a huge save in memory because only these will be created. There is one drawback to this, which I will mention a bit fast, that is, if one of the instances do want to change the keys, then we will need to make a copy of this inside that instance and modify, and that would be slightly more expensive. But that is not something that happens as often as the other things. So actually this is very good optimization. And this leaves us with the last one I wanted to show you, which is what I find very interesting about this one is it's a very special case that they have separated. But this goes to show the level of caring that goes into crafting dictionaries. So, all operations within dictionaries at some point require comparing keys. Imagine I'm trying to look for the key, for something in a dictionary. And comparing keys can be complex in Python. I'm talking at the end of the day of comparing objects. So I have to go fetch for the direct of one, see if it's defined, the comparison. If it's not, I have to go fetch the direct of the other, see if it's defined. These can all raise exceptions. So it's very complex, and there are a lot of cases we need to check. But, and this is beauty, with the strings it's different. If I have two strings, none of this can happen. None exceptions, and it's always defined. So here goes the level of detailing. String comparisons are handled differently. And this is, as I said, better, but it's also great because most of the internal Python dictionaries have keys that are strings. So this optimization not only works for your dictionaries, but is improving the language itself. So I find it quite fascinating. The amount, and these are just 3 examples, so the amount of optimizing that you can find is quite impressive. I really hope you enjoy this talk. I'm gonna tweet these slides later. They also have references. And I really hope you like it, and I have sparked your curiosity to go read more about this. Thank you.
Gisela, that was very informative. Will you be around later to talk to the people?
Yeah, sure. Until Tuesday.
Yeah. Thank you very much all for attending, and enjoy your lunch. Thank you.